Hi folks, and welcome back to Physics with Captain Rod. I'm making this video here to help you out with a couple homework problems out of your OER College Physics textbook. In Chapter 2, we're going to chat about numbers 55 and 56, starting with number 55. Now, I guess before I get more detailed about 55, I'm going to point this out, that both of these problems have to do with, you need the following things. One, you need to be able to calculate the field, the magnetic field around an LSW, a long straight wire, which remember is mu sub O over 2 pi I over R. And as you're working this, if you just want to put like some constant times I over R and put that in last, that's perfectly fine. And then second, when you have a wire of length L within a magnetic field, the magnetic force on that wire is given by IL cross B, where this I is the current within the wire itself. So when we take a look at number 55, here's kind of a rough picture of it. And I'm just going to do this in variable form. You folks can fill out the details here. We've got a current to the right. I called it I1. It's 15 amps. We've got a current counterclockwise in this loop of 30 amps. I called it I2. Distances A, B, and L, all given in the problem there in the picture. Now, remember the field lines around I1. They're going to be circular, and they're going to look like this. And any point down here, those fields are going to be in the minus k direction in a standard x, y, z coordinate system. So you're going to get fields along this wire right here. Now, these distances are not changing, so the magnetic field here should be the same as here, should be the same as here, and so forth. And you can calculate that field strength using this. Next, right, then you have to realize we have a current I2, which is this way through that magnetic field. So first let's talk direction. You want to use your right hand, fingers in the direction of the current, rotate so you can sweep towards the magnetic field vector. And I don't want to give that fun away, but I'll tell you it's either going to be up or down. Right? Then calculate the magnitude using I2 times this length times B. Now the B you're going to use is the one you calculated from current 1, right? And then don't forget times the sine of the angle between this current and the magnetic field. Now this current I have drawn, notice it's to the left, or what I would call the minus I direction. These magnetic field vectors are into the page, or in other words, the minus K direction, and I'm going to let you figure out what the angle is between them, okay? Basically now repeat for I2. You're going to find field direction, whoops, you're going to find magnetic fields along this wire. And then find the force direction between those magnetic fields interacting with I2. You should get the opposite of as you did here. And then calculate I2 L cross B. Oh, I might have forgot, calculate the magnetic fields here, which are mu sub O over 2 pi I over R. The R will be this total distance, what I wrote as A plus B. And then the net magnetic force is the vector sum of the two. You might be asking about the wires on the left and the right. You can go ahead and consider them. What you're going to find is they're going to be in opposite directions anyway. They're going to just add to 0. These are going to be in opposite directions as well, but the force on this wire is going to be stronger than this one because it's closer. Let's chat a little bit about 56. And I'm just going to do like one of these. There's two pictures here. There's actually quite a bit of work in these two problems. The picture on the left, we've got a 5 amp current, which if you don't mind, I'm going to call it I1. And then a 10 ampere, which I'm going to call I2. And then a 20 ampere, which I'm going to call I3. Let's see, find the direction and magnitude of the force that each wire experiences in this picture by using vector addition. So that's actually a lot of work because there's 3 different wires here. I'm going to talk about how to do one of them. We're going to talk about how to get the force on this wire right here. Start by finding the magnetic field here due to this 10 amp current. Remember that the field lines are circular. In fact, I'll go ahead and draw that one in for you. That field is going to point something like this. Whoops. I've got a new computer screen here and it's giving me a little trouble. Something like this, where it's going to make a right angle. That field is equal to mu sub O I2 I'm sorry, mu sub over 2 pi I2 over this distance. Repeat for the 20 amp current. That's going to give you something up and right. Calculate the magnitude, mu sub O over 2 pi I2 over R. Then, once you have these two magnetic field vectors, add them together vectorially. Then you can do this current I1 crossed with that magnetic field vector. Repeat for this one and this one. So it's kind of a long problem, right? But that should at least get you rolling. And I'll try to make videos here once I get this computer, or more videos for you once I get this computer screen figured out. So that'll get you rolling on these two. This one by far is the more important of the two. Make sure you get this one done to the completion and in good detail. All right. Have a great day.